Okay, so here we have polynomial division. In this specific instance, I have three terms, currently at least, being divided by two terms. We're going to show it in two different ways. We're going to show long division, that's why I have this little template here, and that's going to be kind of our first way. It's in the name, it's probably the longer of the two ways that we're going to go through it. We're also going to talk about kind of a shortcut way with synthetic division, but the only issue there, the drawback, is that it only works for certain problems. It does work for this one though. All right, let's go ahead and go through long division first. So with our setup here, we're going to rewrite what would be typically the numerator underneath here. And if you notice as I'm going through here, obviously I'm going to need a little bit more room. I have the exponents in descending order, so 3, 2. I'm missing my one term, so I'm going to need a placeholder for that. So I'm going to put a 0x. Again, that's a placeholder for that spot where there's an exponent of 1 on the x, a constant. On the outside, I'm going to have that x minus 3. With both of these methods, it's going to be a process of finding a few unique steps and then repeating and repeating until we've worked out an answer. So the first thing I need to do is I need to ask myself, what times this first term out front will multiply to give me this as a product, or as an answer. So what times x gives me 2x cubed? In this case, it's going to be 2x squared. And I'm going to put that above the other x squared. When I actually carry out that multiplication, so this times this, I get 2x to the third power. And I also need to multiply by my other terms as well. So in this case, that's the minus 3. I'm going to get negative 6x squared. From here, we're going to turn this into subtraction. So I'm going to subtract. These are the same thing, so if I subtract one from the other, they cancel out. If I have a negative 7 and I subtract a negative, that's like I'm adding. So I'm going to have negative 7 plus 6. That would be negative 1x squared. And finally, before I start to repeat the process, whatever the next term is, drops down. So in this case, that's that 0x. That's why I need that 0 there. Otherwise, I'd be dropping down the wrong thing, and I would be trying to combine like terms in the next step that aren't like terms. I would have, for example, x's going with constants or something like that. All right, I'm repeating this process now, so I'm asking myself, what times this first thing gives me this now? So that's going to be a negative x, or negative 1x. If I carry out that multiplication, I get this again. But then negative 1x times negative 3 is positive 3x. Just like before, I'm subtracting. Just like before, these cancel. Same steps over and over again. 0 minus 3 this time, so it's going to be negative 3x. I'm going to have one more round of work as I drop down this 5. I need to ask myself, what times x gives me negative 3x? So that's just a negative 3. When I carry through the multiplication, those match, and negative 3 times this negative 3 gives me 9. Subtract one last time, this cancel. 5 minus 9 is going to give me a negative 4. Now that I have nothing left to drop down, I lined these all up as like terms, so I have no room left. My degree here is less than what I had out front, are all ways of catching myself and telling me that I'm finished. This, if it's not a 0, which it's not in this case, is a remainder. So I would write that as, because it's negative, minus, and then 4 over whatever I'm dividing by. So what I wrote up top here would be my answer. It's what I'd get if I simplified this division that we started with. So we'd have a polynomial that is 1 degree less, and it does have 3 terms still and a remainder. Let's switch gears here. And we're gonna try to squeeze in the synthetic division without having to erase that. I should have planned a bit better with my space. But I want us to see how it's similar and how it's different. And that way you can compare the two. So just like this setup here, we're gonna have a template that we're gonna follow. We have room for a specific value up top. We're going to create a row of numbers across the top. We'll get our answer along the bottom. And then what I have with this kind of separator here is going to leave me with my remainder, kind of like down here. The number that goes in that top corner is whatever would make this 0, which in this case would be a positive 3. With synthetic division, I mentioned you can only do this with certain division problems. It's only when you have the thing you're dividing by is a variable plus or minus a constant. Exponent has to be 1, coefficient has to be 1. It's only going to work out that way, or at least the way we're doing it right now. We see that if it's in this form, it's pretty much always going to be the opposite value of this. So negative 3 gives us a positive 3 here. All right, I mentioned I'm going to have a row of numbers across the top here. It's going to be the coefficients from this, and I do need the placeholder here as well. So I'm going to have a 2, a negative 7, a 0, and a 5. No matter how many terms I have, the last one's the one that goes on the other side here. And finally, I can start into this process of repeating. I'm going to basically have multiplication and addition back and forth. But to do that, I have to have something to start with. So I'm going to start by dropping that 2 down. The first number always drops. I'm going to start with multiplication between whatever's in the box and my most recent number on bottom. So 3 times 2 gives me 6. And then I'm going to flip to addition. If I combine those, I'm going to get negative 1. And then I'm flipping back and forth here. So I'm going to go to multiplication again. 3 and negative 1 gives me negative 3. Flipping back and forth again. Combining, that gives me negative 3. And one more multiplication. 3 and negative 3 gives me negative 9. One more combining or adding here. I get negative 4. If you look at those numbers there, they match our coefficients and our remainder just without the variable aspect. So we have all the info we need, we just need to rewrite. If we're in a situation where we can do synthetic division, it's going to be just one exponent less in the answer than whatever we started with. So I'm going to have x squared, an x, a constant, and a remainder. And then we'd be able to set up just like last time. So hopefully this is helpful. Remember, this way is longer, but can be used for anything that we're dividing by. Synthetic division has to be in this kind of form here. Hopefully that helped. And we'll keep hopefully adding new videos here soon.